Lesson 3.2 is secant line limits numerically. So we've learned that a secant line is really just a regular line where it touches 2 points on something curved. And what that allows us to do is find an average rate of change. So all those words mean the same thing. Average rate of change, secant line, you're still really finding slope. Our function is right here. It's a 2x squared minus 24x plus 62. We've got it graphed. Determine the slope of the secant line of f for each of the intervals located. So we've got different intervals here. Kind of time consuming, but pretty simple. So we're finding the average rate of change of f on the interval from 7 to x sub 2. Brackets always mean that these are x values. That is not an ordered pair. So we're going from 7 to something different, and we're going to do it for these 4 numbers in the table, and write your answers decimals. We don't want to round. Okay, so if I'm going to do the first interval, my interval goes from 7, and then I would stop at 8. So I'm wanting to find the slope from 7 to 8. What that's meaning is the point on my graph here at 7 and at 8, if I were to connect them, what's the slope? We are doing y2 minus y1 over x2 minus x1. But I am going to start using this f of these things just so you can get used to that format. So my slope is going to be f of 8 minus f of 7 over 8 minus 7. So the bottom part's always easy. 8 minus 7 is just 1. The top part takes a little bit of time because I want to probably graph it would be the fastest. So see how I've got my function put in here, my y equals. I'm going to go to graph. Now I go back to second trace, which is calc, to calculate, and I want a value. I want to know when x is 8. That's what f of 8 means. What is y when x is 8? That is negative 2 minus, now I want to do it again. You don't have to press anything other than 7. When x is 7, I get negative 8, which will turn into plus 8. So that would be 8 minus 2 is 6 divided by 1 gives me a slope of 6 is the average rate of change. So if this is super struggle for you, think about you're creating a point at 7 comma something and then 8 comma something. When x was 7, we said that it was negative 8. When x was 8, we found out it's negative 2. And see how we did negative 2 plus 8 and 8 minus 7. That's it. Okay, number 2. Now our interval still starts at 7, but we're going to 7.1. So only a tenth away. So my slope would go f of x2, or 7.1, minus f of x1, which is 7, over 7.1 minus 7. The bottom, that's only a tenth difference. That subtracts to be 0.1. And then I need to find when it's 7.1, what is y? Negative 7.58. I already know what f of 7 was. I've already done that. That's negative 8. So minus negative 8 turns into plus 8. So now I have to actually do the math. Oop, second quit. Negative 7.58 plus 8 divided by 0.1 gives me an average rate of change or slope of 4.2. So notice how it got something different than 6. Next interval would be going from still 7 to now 7.01. So my formula is going to be f of 7.01 minus f of 7 over 7.01 minus 7. On the bottom, that subtracts to be 1/100th, or 0.01. I need to go back to my graph, second calc, value, and put in 7.01. Don't round. So negative 7.9598. For this, and then minus, we already know that it was negative 8, so that turns into plus 8. So you're going to have to second quit and do the math. Divide that by 0.01, 4.02. I'm hoping you start to see a pattern here. So that's the slope. And then one more interval, you're going from 7 to now 7.001. That'll be f of 7.001 minus f of 7 all over 7.001 minus 7. So on the bottom, we're going to get a difference of 0.001. Graph, second calc, value, 7.001. Ooh, write all of that. Let me scoot down a little bit. Negative 7.995998. Second quit. Oh, I forgot my plus 8. That could have been bad. So this was all this y value minus my negative 8 or plus 8. And then divided by 0.001 gives me 4.002. So what's the pattern that you see? You see our slope was 6, which was really just counting up 6 boxes, right 1. You could have just counted from the graph. But then what happens is we move the points in closer and closer to the one that's already made here at 7. That creates the line to lean a little more and get more accurate. So it's kind of like when we did the tables with limits, we're getting closer and closer to a slope of actually 4. That's really probably what the slope is when x is 7, is more like 4 instead of 6. Now we do have one more problem. I'll go faster on it. It just looks slightly different. Number 2 has a different function. We're still finding the average rate of change or the slope of the secant line. But look, it starts from 2 and then goes to 2 plus h for each value of h. So these values get plugged in right here for h. So my first interval would still start from x is 2, but then I'm adding 2 plus 1, which would be 2 to 3. So all you're doing is finding your slope or your point at 2, your point at 3, which this one I could probably just look at and tell, because I'm doing f of 3 minus f of 2 over 3 minus 2, which the bottom gets 1. When x is 3, y is negative 5. Oh, they switched it up on us. So that actually might not be a good idea, because that's negative 5. That would be negative 7.5. Should be 2.5 over 1. But I better check. So I went ahead and graphed this. And I want to see second calc value when x is, let's do 3 first. When x is 3, negative 4. See, yeah, that didn't work. And then when x is 2, it's negative 8. So yeah, that definitely does not look the same. So that would be plus 8. 8 minus 4 is 4 divided by 1, 4. And then what happens is you move in. So the next one will still start at 2, then it's going to do 2 plus 0.1, which is actually 2 to 2.1. So then your slope would go f of 2.1 minus f of 2 over 2.1 minus 2. So that would be 0.1. Figure out when it's 2.1, y is negative 7.69. And then a good thing is, again, I already know that this was negative 8. And so then I'm just going to add 8 to that. And then divide by 0.1 is 3.1. So it starts to get a little more accurate as I move in closer and closer. So see if you can do these last 2 ranges. And so these would be your ranges. 2 to 2.01, you should get a slope of 3.01, and then 2 to 2.001 should get a slope of 3.001. So don't always assume that it goes in this pattern, but it is kind of cool to see that, again, having a distance of 1 apart made the slope be different, but then as we start getting closer and closer, the points are getting closer to 0 here, which is the definition of a limit. We are actually zooming in or getting closer to having a slope of 3. This is what the lesson is wanting you to understand.